Okay, so you've joined the Modern Performance Best Practices. My name's Dustin Whittle. You can find out a bit about me at dustinwhittle.com or follow me on Twitter at dustinwhittle. I'm currently a developer advocate at Uber, and before that, and a lot of the experience of this talk comes from my experience as a developer advocate at a company called AppDynamics that does application performance monitoring. So this talk is meant to be general purpose. Most of the concepts apply to any language. There's going to be some tools that I mentioned that are based on Node.js. So if you don't have it installed, go to nodejs.org and install Node.js, which comes with NPM, the Node Package Manager. And that's all you're going to need for all the tools that I'm going to show. So the reality is, why does performance matter? Application complexity is really exploding in the last decade. When I got started, it was just a front-end web server and a back-end database, and that was the whole deal, even for like high-powered sites. Maybe you have a couple database slaves. But the reality is modern web applications are much more complex than this. The rise of service-oriented architectures and all these microservices means that performance is really a much harder problem these days, because it's not just optimizing the web server and optimizing the database, it's optimizing the entire stack. I always like to start this talk with why performance matters. The reality is that performance directly impacts the business's bottom line, and you should be able to quantify why you're investing in performance. So to that effect, Amazon increases revenue by 1% for every 100 milliseconds they shave off the end user experience. Mozilla shaved 2.2 seconds off their Firefox download page, and they got 60 million more downloads as a result. So again, the reality is that performance directly impacts the business's bottom line. And the same way you think about unit and functional testing, you should think about performance testing. So how fast is fast enough? How does your brain perceive page latency? Well, 0.1 seconds or 100 milliseconds, it feels instantaneous, like you're flipping a page in a book. You don't lose your train of thought or your context, but after about a second, people start to lose the context. And it's proven that after 10 seconds, people will abandon your website together. This is even worse in a mobile world, where not only will they abandon your site, but they'll also go to the App Store and rate you horribly. So you should really try to concentrate on not just the back-end latency, but the end-to-end latency. So I'm going to be talking about both the server side and the client side. So again, how fast is fast enough? These are some key metrics I like to go across. Under 100 milliseconds is perceived as instantaneous. 100 milliseconds to 300 milliseconds, the delay becomes perceptible to the user, so they're going to start to notice. And about 3 seconds is the maximum for keeping people's attention span on a website. And the reality is that modern web applications, you spend way more time in the client side inside the browser than you do on the server side. The 100 milliseconds or 200 milliseconds that it's taking for your web app to respond is nothing compared to the 4 or 5 seconds the user's waiting for the page to become interactive in the browser. So let's go over some principles of scaling server-side applications. The first one is caching. Caching seems straightforward, but cache as much as you can on the client side and on the server side. I think most front-end developers are experienced with caching JavaScript and CSS, where you want to set a far features expires header so that you don't download fonts, CSS, JavaScript every time the page loads. Well, you can do the same thing with reverse proxy cache on the server side. So instead of having to hit your server and having the application process the request to generate a new response every single time, you can cache it in a reverse proxy cache. The next is queuing. Don't delay the user experience for tasks that can be executed in the background. Never make the user wait for something that's not required for the next response. And then the last is going to be doing work asynchronously. Try to optimize for running things concurrently. So let's walk through each one of these. First, you should try to leverage HTTP caching. Like I said, most people are familiar with the idea of caching from the front-end perspective. For static components, you should implement a never expires policy. So with this, you can set the expires HTTP header to a far future date, and then the browser is not going to request that asset until that date passes. But oftentimes, you want to apply this to a website, and websites have dynamic content. So then how do you do this when the content changes frequently and you need to validate the content? So for dynamic components, you can use the validation strategy and use an appropriate cache control header to make the browser conditionally request assets. So we'll dive into all of these really quickly. So this is a really amazing flowchart that shows when Alice goes to /welcome, it goes to the cache. There's nothing in the cache, so it goes to the back end. And the back end returns with the HTTP status 200, and then hello world is the content. It serves it through the cache, and then serves it back to Alice. So this is the standard HTTP request and response flow with no caching involved. When I talk about caching on the server side, I'm really talking about caching with a reverse proxy cache like Nginx or Squid or Varnish. So how does this work in the expires or invalidation model? There's two ways. I can tell you a date and don't ask me for this resource again until this date pass. And then there's the validation model, which says check with me every time you request this resource, and I'll tell you if this resource is still valid and if I need to generate it again. So again, the expiration model is pretty straightforward. Alice goes to /welcome, request /welcome. Nothing exists in the cache, so you make a request to your backend service. The backend service generates a new HTTP response, in this case, hello world. But now it's going to include a max age header. The max age header says don't request this asset until this time passes. So it's going to return a response back to the cache server. In this case, it's HTTP 200 with a cache control header of max age 600 seconds. So don't request this asset again for a few minutes. That'll return back to Alice, and the next time the request comes along, we won't actually have to make the request to the backend. So Bob comes along just a minute later, or 30 seconds later, and I request the same asset, /welcome. It goes to the cache, and the cache still has an asset, and 30 seconds hasn't, it's only been 30 seconds, so the asset is still valid, and it returns it directly from the cache. So there's no request to the backend. So with caching, the goal is to alleviate the load on the server side. It's not necessarily that you're optimizing or getting more efficiency out of your application server. It's that you're getting more efficiency out of the end-to-end experience. So in this case, because there's no request to the back end, you skip the processing time, and now the cache is still valid, so it's going to return it to Bob. Again, a 200 HTTP response within age of 30 seconds because Bob showed up 30 seconds later, and now the cache control max age is still 600 seconds. So this is pretty straightforward. This works for JavaScript, CSS, and HTML pages as well. If you have a very static homepage, this is a great strategy for caching your homepage for up to 1 minute. But oftentimes, the reality is that caching is really difficult because the components change. Maybe you're logged in and you want to cache per user. Maybe the top 10 headlines change every 30 seconds. So this is where the validation model comes in. So again, there's two models. There's the expiration model and the validation model. The expiration model we just walked through. I set a time. Don't ask for this resource again until this time passes. And then there's the validation model. With the validation model, you really want to check with the backend service. Is this still valid? Is the resource I asked you for previously still valid? So Alice comes along and requests /welcome. There's nothing in the cache, so the cache makes a request to the backend machine. It generates a HTTP 200 response with hello world as the content, except for this time it also specifies an HTTP header of last modified as well as an E tag. So an E tag is simply a unique ID for this resource at a given time. And then the cache will return this to Alice, and then you've basically saved the backend one single request. Now, and Bob comes along just a few seconds later. Bob requests /welcome. There's something in the cache this time, but the cache was generated on Tuesday, October 28th. So you want to check, is the cache still valid? Has the last modified date changed? If so, then the backend will simply respond with a 304 not modified response, which is way lighter weight than generating a new 200 response with the entire response content. So the goal with the validation strategy is, one, you're always going to make a request to the backend service, but the request should be lighter weight because all you need to do is confirm that the content is still fresh or valid. Because it's a 304 not modified, it's going to send the content back and say, okay, last modified was again Tuesday 28th of October, and the E tag is still the same. Okay, now sometimes you want to combine both strategies, which is very easy to do. So I only want to generate my homepage every minute, and then even if you make another request after a minute's passed, I only want to generate a new homepage if the content's actually changed. So you combine both models very easily. Here, Alice comes along to /welcome. There's nothing in the cache, so the cache goes to the backend. The backend generates a new HTTP hello world response with 200 status code. This time it specifies both a cache control header as well as a last modified time. So here the cache control header is a max age of 60 seconds and the last modified timestamp. And that'll return back to Alice. Now Bob comes along 30 seconds later. It's not going to make a request to the backend. So Bob comes along, there's something in the cache, so instead of going to the backend, it'll skip that interaction. Now you'll see that, again, the age is 30 seconds, the max age is 60 seconds. So we generated this 60 seconds ago, only 30 seconds has passed, but the content was actually last modified on this date. So Carol comes along a few minutes later and says, okay, I want to generate the same asset. I go to /welcome, there's nothing in the cache. So I actually make a request to the backend because there's nothing in the cache because over 60 seconds has passed, so I still need to validate it. But I might not actually need to generate the response content again. In this case, the content's still good, so I send a 304 not modified header, and I increase the cache control max age. So again, the max age is an additional 60 seconds, so now the content's fresh for another 60 seconds, and it returns it back to the user. So at a high level, this is HTTP caching, a simple crash course. And there's some strategies for how you apply different models of caching. Is the request reusable? Then you should cache it if you need to revalidate it every single time. Do you want proxy caches? Like ISPs oftentimes will have caches that they cache for a whole subset of users. Do you want it cached by that? Like New York Times or Google.com, something like this is highly cacheable. And if not, then set it to private and share it directly with the client. But some best practices to actually make caching work. One, you need consistent URLs. If the URL changes every time, then you sort of invalidate the cache automatically every request. You want to generate a valid e-tag. So for an example of a good e-tag, if I have a blog post and a blog post has a set of comments and an updated at date, I might just MD5 the blog post ID, the updated at timestamp, and the number of comments. And if the updated timestamp changes or the number of comments changes, then I actually need to generate a new response, and that'll give me a new unique e-tag. But caching really comes down to the user workflows of the application. There's no one single rule that works for all applications. It really depends on the specifics of your content and the usage pattern of your users. Okay, so caching, again, at the high level, the goal is to just alleviate load on the server side, and most people already do this on the front end. So the next one's queuing. So any process that is slow and not important for the next HTTP response should be queued, and the work should be done in the background. There's a variety of ways to do this. There's messaging layers, and there's task and queuing systems. But the idea is that you should queue work to be operated on in the background and not block the user's request. So a good example of this is if you're trying to send emails or posts to Facebook or social networks, if you need to do push notifications, if you use location and you also use a social network, it's fine when the user has 10 friends, but if a user has 10,000 friends, all of a sudden this can take a very long time. And then analytics and instrumentation. So let's walk through a real example. Most of the time, a user submits a form. You need to update the database. Maybe you want to invalidate the cache. Send an email because they just processed an order. Send a notification that says, hey, your order is processing. And then maybe there's some location context, so you need to update their location and then refresh their friends. So each one of these things is quite fast. So updating the database is 200 milliseconds. Refreshing the cache is 100 milliseconds. Sending emails is a little slow. Sending notifications is a bit slow. And then recommending new friends is a bit slow. The idea is that the user has to wait 3.7 seconds for this entire interaction, just to show them the next page. But most of this work is not actually required to see the next page. I don't actually have to validate that I've sent you an email or posted to your social network. I just need to make sure that it happens in the background. So a better model for this is if a user submits a form, you really just need to update the database and then create a task or create a set of tasks. In this case, send orders to the backend for processing, and then do all the work in background jobs. So before it took 3.7 seconds, but now it only takes 300 milliseconds. So you shaved off all of that latency by just moving the work to the background. And what you can see here is we have background jobs for each one of the tasks, invalidating the cache, sending emails, sending notifications, and then refreshing friends based on location. So the benefit here is twofold. One is that you get better performance. You decrease the latency because you're not blocking for all of those different tasks. And two, you get increased scalability because you can dedicate more workers to processing each task. So if I all of a sudden have 100,000 users show up, I can just add more machines on the back end to process each one of these task queues. So at a high level, I think these are general practices that apply to most modern web applications across any language. You should use caching, you should use queuing, and you should try to work in an asynchronous model. But most of this talk is really focused on the front end because the reality is that in modern web applications, more latency comes from the client side than the server side. 80% of the end user response time is spent in the front end. So most people spend a lot of time optimizing the back end, and they argue about things that take 10 milliseconds or 20 milliseconds, but that's nothing compared to the 4 or 5 seconds that people are waiting in the browser for the page to actually become usable. So let's talk about some common performance best practices for front end performance. It comes down to a couple of different things. You can reduce the number of HTTP requests that are being made, you can reduce the size of the HTTP request, or you can make the request more efficient. So to reduce the number of HTTP requests, avoid redirects. I have this really amazing website, DustinWhittle.com. It has just my name and a bunch of links. But because I borrow this Google Fave icon service to give me an icon for every one of the links that I show, every one of those links shows up in a redirect. So now it means for the 10 images I want to load, I now have to make 20 HTTP requests. I serve my site over SSL, so if I have to do that, I have to negotiate SSL for multiple domains. I have to do multiple DNS lookups, so all of this starts to add up very quickly, and it's very easy to avoid by just removing the redirects for known assets. I think the most common best practices are concatenate resources and like style sheets in JavaScript. So you should combine these and minify them as much as possible. You should combine images into CSS image sprites, and then you should leverage HTTP caching for front-end assets. Like I said earlier when we were talking about the server side, you can do the same thing for the client side. I think most people know about caching on the client side, but you should never download JavaScript or a style sheet if it hasn't changed, and most of these things don't change dynamically. You push it out with your deploy process, it has a timestamp, and you don't need to refresh it until you do another deploy. So the next is reducing the size of HTTP requests. So you can do this by optimizing your style sheets with minification. The same thing with JavaScript. With images, you should optimize your images. With fonts, you should only use the subset of the font that you actually use. You should use gzip compression for all of these assets. And then you should try to reduce the size of cookies. So a lot of people miss the cookie piece because they don't really think about it. But a cookie is sent every single request. So if you're making a request for images, that's a couple of bytes that you're adding for every single request for an image, style sheet, etc. So you should try to move to a cookieless domain for static assets, and you should try to reduce the cookie size. Most of the time, people put all their session data inside of a cookie, but it's better to put an identifier there or sign it and put an ID there, and then store the data on the server side. Okay, and then the next one's going to be optimizing content. This is pretty basic as well. Move style sheets to the top of the page, move JavaScript to the bottom of the page, make sure your JavaScript isn't blocking, and then try to preload components when you're idle. Preloading can get a bunch of performance benefits simply because when the page is idle, I should preload what I think your next interaction is going to be, or I should start loading images from below the page, below the fold. But there's a bunch of different ways to improve this. And then lastly is network performance and decreasing latency. So reduce the number of DNS lookups, use as few domains as possible. You should try to reduce the network latency by putting where they're requesting your assets from as close to them as possible. That's where CDN, content delivery networks, come in. The goal here is to provide servers all around the world and put your static assets as close to the user as possible. And then for more advanced users, use service workers. Do work in the background inside the actual browser. Okay, so that was a quick crash course in like common performance best practices. Now let's talk about some tools that allow you to understand what's actually going on in your applications and then monitor performance and understand how it changes over time. So if you've been doing any front-end development, you're probably familiar with Google Chrome developer tools. They're pretty amazing these days. Before that, there's the Firefox web debugger and a bunch of other tools. But the idea here is that they all give you an understanding of how the page gets rendered, where the bottlenecks are, what assets and network requests you're making, and you can get some visibility into what exactly is slow. So here you can just see the content body. You can see the number of HTTP requests that are made. What you can see is that I block on a bunch of these and I make a bunch of redirects here. So all of these 302 redirects, that's multiple HTTP requests I'm having to make. You can actually see the content of the JavaScript that's executing, and then more importantly, there's a profiler, so you can see a timeline of what's being executed. Where are you actually loading stuff, downloading it, where are you evaluating the script, and then where are you actually rendering and where are you painting. The idea here is when you really want to start to optimize your JavaScript, you really have to start profiling and dig deep into what's actually happening in the browser. So Chrome Developer Tools makes this incredibly easy with their profiler, so you can really run some JavaScript, profile it, and see exactly where the time is being spent and what's happening the entire call stack. And then sometimes you just want to understand, okay, what cookies have I loaded, what fonts are available, what's the content of those things. So you can get visibility into all the HTTP responses. And then finally, they built Google PageSpeed directly into the developer tools, where you can actually run an audit on the page to figure out which of these performance best practices are being followed or adhered to. And then there's, of course, the JavaScript console that I think everyone's familiar with. So at a high level, you should be using Google Chrome developer tools. If you're not using Google Chrome, you should, and then you should use developer tools. But that's a personal preference. One of the nice things about Google is they've invested heavily in web performance and decreasing the web page speed for everybody. And one of the tools they've invested in is called PageSpeed. The idea behind PageSpeed is allows you to analyze your site's performance really easily. So it's available a couple of different ways. You can go to developer.google.com/PageSpeed, and it's available as a standalone web service. It's built into the Chrome developer tools as audits, and then there's the standalone website. So again, the idea here is all the best practices that I showed you earlier come from Google's site. The goal with PageSpeed is to be able to automate the test for this. So I just want to request my page and then figure out what are the basic things that I should be fixing on the client side. So in this case, I should eliminate render blocking JavaScript. I should leverage browser caching for some assets that I'm loading, and I should minify my JavaScript. All the things that I said up front in terms of client-side best practices, this allows you to easily audit them and figure out which ones you're following. And then there's different profiles for desktop versus mobile because there's different experiences expected. So again, this is available via standalone website, developer.google.com/PageSpeed. It's available as a web service. And then there's a really nice NPM module called PSI or PageSpeed Insights that allows you to do this as well. So it's pretty easy to install. NPM install PSI or PageSpeed Insights. And then you can run the same request. So here I just want to run an audit for my personal website and figure out how I should optimize this. Now, the reason I talk about these tools is whenever I talk about performance, I really like to talk about how to automate it. All of this stuff I try to automate into the continuous integration cycle. So every time Jenkins or whatever Travis CI, Circle CI does a new build, I can get an audit of how performance has improved or degraded over time. If it's exposed via a web service and you can script it very easily, it's very easy to implement. So this will give you an output that looks like this. This is basically a command line version of what we saw on the web page. But my page speed score is up here. Page speed score is 94. And then here are some best tips that I should be following. Leverage browser caching and minify JavaScript. So that's a quick crash course in how to optimize the basics of performance in the client side. But then there's a lot of nuances when it comes to working inside the browser. So at a high level, I'm just going to focus on these. Compress your JavaScript, use Clojure compiler by default. There's a bunch of different ones. I think the most efficient. There's a bunch of different minifiers and JavaScript rewriters for efficiency. The most optimal I found is Clojure compiler. Use CSS. I think a lot of people use a lot of web frameworks, maybe use Zerb Foundation or use Bootstrap. Most of the time, you load all of the CSS and you only use 2% of it. So try using every declaration just once and optimize your JavaScript code. Prefetch resources when you can, and try to understand the critical rendering path and optimize for that. So we'll talk about this in a little bit. Again, I think I touched on some of this earlier, but optimize for content efficiency. Eliminate unnecessary downloads, eliminate unnecessary redirects, optimize the transfer and encoding, optimize your images, optimize your fonts, and try to leverage HTTP caching when you can. Now, if you do this, you'll probably cover all the low-hanging fruit in your application. So let's talk a little bit about CSS performance, and then we'll dive into JavaScript performance. So a lot of people argue which selectors are the most efficient. The reality is that it doesn't really matter much, but you should avoid universal rules. You should not overqualify CSS declarations. Avoid the descendant selector or anything where you actually have to look at the DOM and evaluate it in real time. Rely on inheritance when you can, and don't use vendor-specific features unless absolutely necessary. 5 years ago, this was sort of impossible if you wanted a consistent experience, but nowadays it's much better. And then when you can, especially if you're using big frameworks, use uncss, which will evaluate all the HTML elements you're using, all the CSS declarations, and then we'll strip out all the unused CSS. OK, so efficiency of CSS selectors. ID is going to be fastest. These are all in order of how fast they are. So ID is obviously fastest, followed by classes. Whenever you have to start to evaluate the DOM or look at different attributes, it starts to slow down. When you have to apply state, look at hover or the first element, it gets a bit slow. But the reality is Steve Souders examined the performance impact between the best case and worst case CSS selectors, and the impact's negligible. So it's 50 milliseconds between best and worst case. This really doesn't impact the client-side performance too much, so don't waste too much time on it. Generally, there's much bigger gains to be made by making different changes. So it's not always possible to make changes to the code and improve the build and deploy process, but usually you can access the web server and install a module. So all the things that I recommended earlier can actually be automated through Google PageSpeed modules for Apache and Nginx. But more importantly, you should start with a solid web server configuration. So a bunch of people in the open source world created the HTML5 boilerplate project, and one of the extensions of that is a standard server configuration for Nginx and a standard server configuration for Apache. So it'll automatically set up the rules for caching, for using gzip compression, for serving SSL optimally. So instead of trying to do all this stuff yourself, I would highly recommend that you start with an Nginx configuration from these repos or an Apache configuration. But HTML5boilerplate.com, and then you can check out the server configs. The idea here is that even if you can't change your code, sometimes you can just optimize the service itself to do that more efficiently. The reality is that in most cases, you should actually do this at build time, and you should actually make these efficiencies in your code, but sometimes that's not always possible. One of my favorite tools for evaluating performance of a website is SiteSpeed. So SiteSpeed is like PageSpeed Insights on steroids because, one, it doesn't just evaluate a single page. It'll crawl your entire site and allow you to understand what the performance looks like across the entire site. If you go to the home page and just refresh the home page, that's quite fast. But if you go to the home page, sign in or create an account, sign in, search for a product, add that product to your cart, go through the checkout process, each one of those transactions has vastly different performance characteristics. So when it comes to optimizing performance, don't just focus on the single interaction. Look at how your users use the site and then evaluate and optimize for those user flows. SiteSpeed makes this incredibly easy to do. So again, SiteSpeed is based on Node.js. It's an NPM module, so it's very easy to install. You can npm install SiteSpeed.io. And then you can very easily run a performance benchmark with sitespeed.io-u and then a domain name. In this case, what it'll do is it'll crawl the entire site. It'll use Chrome driver and a real browser instance. So this isn't a simulated request that you're just evaluating based on rules. This is run inside a real browser. And it'll generate a report. So you can get really great insights into how client-side performance looks. But it's not just understanding, okay, is the JavaScript compressed or not? It's also how many images are you loading? Are you scaling the images or are they actually resized? How many SSL connections are you making? How much time are you spending doing SSL negotiation? How many DNS lookups are you making? Et cetera, et cetera. So this is really nice because it gives you this dashboard, which you can easily use as a test artifact and then build rules in to pass or fail builds off of. So if performance, if the page speed rule or the rule score increases or decreases, you might want to fail the build. So if the page speed rule drops by 10 points, then I want the build to fail and I want people to go and evaluate why performance was impacted. But more importantly, it doesn't just do this for a single page, it does it for all the pages in your application. So here we have just my home page, but you can start to understand on a single front-end request, how does it look where the browser is uncached, so I don't have any cache or not primed rather. And then if I make subsequent requests, how does performance look like on a return visit, on the third visit, et cetera. And then again, you can get granular performance metrics across all of your different pages. And these become very easy to scrape out and use as metrics. Now, this is great for a single location. This is great when you're running in maybe a staging environment or testing against production. But oftentimes you want to test against different locations across different network speeds from different browsers. So another great tool is WebPageTest.org. So a lot of the internet companies got together and donated hardware towards this project. So WebPageTest.org allows you to test any browser from any location over any internet connection. And allows you to record the entire rendering process. So it'll generate a screenshot as well as a rendering video. And then it'll give you some of the PageSpeed insights as well. So how does this look? You go to webpagetest.org, you type in a URL, and you get a benchmark. So the idea is just like with Google Chrome developer tools, you get this waterfall timeline of how assets are loading. All of the yellow lines are where I'm making these additional redirects. So these are 2 requests when they could be 1. And then you can see the total page load time. The page load time on the first view and then the page load time on the repeat view, the cache view. And then you can start to drill into these metrics and really start to understand, okay, how does this look? How does this look over 3G or slow mobile internet in India? How does this work in DSL from Poland, right? So the idea here is when you really want to check over different connections, because performance varies quite a bit depending on the latency, the actual throughput, etc. WebPageTest makes it very easy to do. And then again, just like site speed, you can get great performance metrics like first byte time, how much time you're spending using gzip compression, how many assets are actually being used, and then how much are being cached. So again, these are all tools that allow you to optimize your code, that allow you to evaluate the performance of your code in production. But sometimes you actually can't make changes to the code itself, but you can make changes to the web server. I talked about using HTML5 boilerplate for the Nginx and Apache base configuration. But if you can't actually optimize your build and deploy process, PageSpeed has built modules for Apache and Nginx as well. And these modules will rewrite your responses to implement the PageSpeed insights or to follow the PageSpeed optimizations. So if you can't actually change any code, but you do have access to the server itself, you can still make a lot of these performance improvements just by installing one of these modules. So again, it's available for Apache and for Nginx. Mod PageSpeed for Apache and Nginx PageSpeed for Nginx. If you can't make changes to your code and you cannot make changes to the web server itself, then you should try to front the web server with a service that does optimization for you. There's a bunch of these available. Yada is available. I think a lot of people are probably familiar with Cloudflare, but they do the same idea, except for they just take control of your DNS and they filter a request through their service that'll rewrite your responses to be optimal. They'll automatically optimize the images. They'll automatically compress and concatenate, minify, and then compress your JavaScript and CSS. They'll optimize web fonts, etc. So even if you can't control that, you likely have control of DNS, and at a minimum, you can just use one of these services to proxy it. Okay, so before you just start actually trying to optimize performance, you should actually monitor your performance and understand where you're starting from. So monitor performance both on the server side and on the client side. You want to understand the gains that you made by adding caching or the gains that you made by using queuing or adding a messaging layer. You need to get visibility. There's no shortage of people who will sell you a solution to help you with this. There's tons of open source tools that allow you to implement some kind of monitoring. But the idea here is that you should monitor performance both on the back end as well as on the client side. If you don't want to pay for a service, there's a bunch of open source approaches. I'm a big fan of not paying for things and using other people's tools. So monitor your end user latency with Episodes.js. And if you're using Google Analytics, you actually get some of this for free. So Episodes.js is written by Steve Souders, who was an old Google guy who came up with a lot of the PageSpeed Insights initiatives and worked on the Google Dev Platform. He wrote Episodes.js, and basically it's a real user measurement library for JavaScript. You add the JavaScript onto your page. It'll tell you how much time you're spending across all the different loading pieces, and then you can beacon that back to your server. If you're using Google, by a show of hands, how many people use Google Analytics by default? All right, so it's fairly popular here as well. They actually have a site speed sample. And if you go into your Google Analytics dashboard, you can see page load performance for page loads. And one of the things that you can easily do is just increase how often they collect these. By default, they collect a very small sample size, but you can just increase the sample rate to get 100% of your users. And then you get visibility in Google Analytics automatically of how much time you're spending in DNS lookups, how much time you're spending downloading assets, etc. Now, all of these use the W3C navigation timing APIs, or resource timing APIs. But the idea here is that it allows you to get visibility into where you're spending time on the client side at a very granular level. So most people are familiar with, at a high level, the onload event, the request start event, and then the DOM complete event. When you really want to understand what's happening, you need to get more granular than just like how long did it take my page to load overall. You want to understand how much time did it take for the server to respond, the first byte time, how much time did I spend looking up the app cache, spending on DNS, doing SSL negotiation, and then actually how much time did I spend evaluating the JavaScript, executing the JavaScript, and then processing the page, and then finally when the browser can paint the page and the page can become available for the user to interact. So All of this is possible in any browser, any current browser, and most of the end user monitoring tools allow you to use the W3C navigation timing APIs to give you visibility. There's no shortage of tools. Probably some of you are familiar with New Relic. The company I used to work for is AppDynamics. The goal of all these monitoring solutions are to give you visibility into exactly what's going on the server side, what requests are being made to what different tiers, what's going on the client side, how does that look for your real users around the world, and then when you're actually having issues, allow you to drill down into a single request and understand where that time is being spent. So I'm not here to pitch you on a particular tool. My goal is that you should be using something. There's open source equivalents with with Episodes.js. There's Google PageSpeed. There's no shortage of the open source monitoring tools. So pick whatever works for your stack, but you should be doing monitoring. And before you try to optimize, you should start to understand where you're starting from so you understand the efficiencies along the way. Okay, oftentimes people spend, I just like to note this, a lot of time people spend a lot of front-end time loading ads and then loading instrumentation and analytics for those ads. There's a great library called Analytics.js that allows you to do this with one single JavaScript library, so it'll support every analytics solution there is. You should definitely take a look at it. It's an easy way to get rid of a bunch of JavaScript off of your website and start to still keep the ability to track analytics. And then in an HTTP2 world, things are very different. And the reality is that today's best practices are tomorrow's anti-patterns. So all the things that I just talked about using compression, about combining your assets into a single file, about minifying them, these are actually anti-patterns in the HTTP2 world because HTTP2 is built to solve these problems. So in HTTP2, you should unshard your domains because that's not going to be an effective way to decrease the latency. You should unconcatenate your CSS and JavaScript and unsprite your assets. There's a great book from Ilya Grigorik, who is a developer advocate at Google on high-performance browser networking. You can get that book for free by going to this URL. It's a really great read if you like performance stuff. Okay, so I went pretty quickly through all of this, so let's recap a couple of takeaways, and I'll give you guys some resources to follow up. So treat performance as a feature, because the reality is that it does really impact the business's bottom line. It's a really hard thing to quantify for the people, for managers, for an executive team. Oftentimes, it's really hard to ask for more resources or time to go and improve things that aren't visual. There's not a shiny thing at the end of it, so it's hard to justify that to an executive team. You can use some of the statistics that I've given you to create a real business case for this. Again, nobody cares about performance until the website's not working for people, and then you can have whatever tools and resources you want to get things back online, right? That's generally how IT and support operations work. So try to leverage this and start to start doing feature development with performance in mind, and start doing the same way you do unit and functional testing. You should add performance testing. It's part of the software development lifecycle. You wouldn't push code to production without some sort of functional or integration test. You should do the same thing for performance. Implement caching and queuing to improve the server-side latency. This is pretty basic. Start with a solid foundation. Google Web Starter Kit. If you're starting a new project, there's Yeoman, there's Google Web Starter Kit. There's a bunch of different tools that allow you to generate a new project with best practices built in. And so try to start with a solid foundation when you can, but more oftentimes you need to actually make these changes to your code. So leverage Nginx and Apache boilerplate for sane web server configuration, so you don't have to manually do that. Follow the best practices to optimize the delivery of JavaScript, CSS, images, and fonts. And then optimize for the critical rendering path. The initial page load, what do I need to show the user the initial screen to allow them to start interacting with the page? That's what you should optimize for. Everything else should be progressively loaded after the fact. And then use Google Chrome developer tools. I mean, for profiling, it's definitely your friend. Try to automate build and deployment best practices with either Grunt or Gulp or some sort of build automation tool or task runner. Use PageSpeed Insights, SiteSpeed.io, and WebPageTest as part of the development cycle. All these tools can be scripted and automated, so they can be integrated with whatever you use for CI. And then if you can't actually improve the code, then try to leverage a web server module like Mod PageSpeed or Nginx PageSpeed. And if you can't do that, then use an external service that takes over your DNS like Yada or Cloudflare. And then make sure you monitor the real user experience and understand performance both on the server side as well as the client side. Most of these tools come from Google, or most of these performance tips and tools come from Google. They have a great tutorial on Google Web Fundamentals, which walks through all of this step by step. If you really are starting a brand new project, I highly recommend the Google Web Starter Toolkit. It's a standard project that follows all these best practices and gives you great examples for how to apply service workers and a bunch of other cool things to improve performance. And I stole a lot of this content from great people. Definitely check out Automating Workflow by Adi Osmani. The book that I recommended is available at highperformancebrowsernetworking.co/HTTP2. And then if you guys really care and you want a step-by-step course, Udacity and Google have worked together to offer an actual education college-style course on web performance optimization as well as browser rendering. So I've stolen most of this content off the internet from awesome people who are way smarter than I am, and you can find all of these slides on speakerdeck.com. And I think I have just a few minutes left, so I'd like to open it up for any questions that anyone's has. I know I went through that in record time, by the way, so feel free. Not everyone all at once. Anyone. So SiteSpeed.io and WebPageTest can be run locally, and you can very easily run them in a local network or in an on-premise environment. PageSpeed Insights, actually something I cut out of this talk is something called ngrok. Ngrok basically pokes a hole in your firewall and exposes something that's running on localhost using a NAT to basically expose it to the external world. And you can very easily test using a public IP by using ngrok, although all your IT people probably hate me for saying that. Any other questions? All right. Well, thanks for joining. Again, the slides are available on speakerdeck.com. I'll be around for the rest of the conference. I'd be happy to help or take any questions. Feel free to reach out via email or Twitter, and enjoy the rest of Dev Day.